about very common, important subject, which is sorting. All the time, you will need to sort data, all the time. In my opinion, that is very important subject, but today's subject is more important. In my opinion, it's more important. And in my opinion also, it is the most important subject in the whole course. I'm not exaggerating here. Can you guess what is that subject? What is that title? Anyone can guess before I go there? Don't open your...
To order data.
Orders data, loops. Okay, someone said loops, order data. Wallahi, order data is very close. It's very close. Order data is very close.
Algorithm. You are saying what is the meaning of algorithm?
No, I'm saying one of the most topic, one of the most lesson, one of the most title subject in M269. Just guess. Someone said to find data. Someone said loops. Search because we need data. Okay, I agree with that. Okay, I agree with that. Search, in my opinion, is one of the most important topic. Any program should have search. Any application should have search. So I can, والأخت الكريمة who said find, it's almost the same. يعني ما في فرق بين finding or searching data or finding data. Okay. Now, question. If I'm looking for something in this slide, lecture 7. So is there any facility in PowerPoint that I can search?
Yeah, Control F.
Thank you very much. Thank you. So if I just click Control F or any other way, okay. So now I will search for example, let's say KMP. Find next. So there is KMB algorithm. So okay, now I know that they will talk about KMB somewhere because KMB is one of the searching algorithm. Okay, so now you got my point. If you have a database for students, then search. I'm not saying the others are not important. All of them are important, but the most important is searching. The most used. Look at Google. It's one of the most important websites, I believe, in the web. Agree with me or not?
Yes.
I believe all of us are using that one. I think it's the most website used on earth. I believe that. So searching is very, very important. Searching is the action of locating, searching, finding, getting, reaching a particular item among a mass. What does it mean, mass? Mass of other items. Group or big or huge, okay, or large item. So I have in the Arab University, مثلا 50,000 students. So how can I reach to Ahmed, to Khalid, to Arwa, to Jamal, to Munira, and so on. So I can just, as I did when I try to find KMP, I will do the same there in a way or another. So searching is very, very important topic. We have, like the sorting. In the sorting, we talked about bubble sort. We talked about insertion sort. We talked about what? Selection and insertion sort. We talked about merge, quick sort, merge sort. And I told you, we have many others, but we cannot cover them in this course. You might look at them in some other courses or just for your more knowledge. In search, we have also many. We have sequential search we have binary search. Okay, we have KMB search, we have hashing, we have binary tree, we have AVL tree. All of that will let you search about data, search about data. Linear, that is the sequential. Binary, quick select, it's similar to quick sort, by the way. Okay, hashing, then we have a basic string search, a KMP, KMP algorithm, then we have a binary, then we have an AVL3. AVL3. Let's start. Linear search. Sometimes you will find it as named sequential search. So we are talking about the same thing. Sequential, one after another, one after one. In the linear search, it's a very simple search. That is the normal. If I have 100 students in my class, in my case now, right now, in my case right now, let's see my case. If I need to know student, so I have the list of the students, as you can see. Ibtisam, Umar, Abdullah, Daniel, Juria, okay, and so on. See more, then you will have more and more students. So now, if I need Alma Nizar, okay, I might just click and do whatsoever. Okay, or ask her question, or ask her for opinion. Or... Now, if I want to do it sequential, okay, if I need to do it sequential or linear, so what does it mean? It means that every item is checked, every item. If match, okay, in another word, found, then that item is returned. Otherwise, the search continues till the end. This is very important, till the end. So let's say that I am looking for Muhammad. So Muhammad no, Muhammad no, Muhammad no, Muhammad no, Muhammad no, Muhammad no, Muhammad no. So I will just keep trying to find Muhammad. Yes, that's the one I'm looking for, Muhammad Ahmed. So should I continue? I found what I want. Should I continue? Yes, no. Is it practical? Is it logical that I found Muhammad Ahmed? Should I continue or exit? No. Logically, no. Logically, no. I found what I want. So why should I continue searching? Okay? So this is point, very excellent point from you. Next, if I go to the end of the list, let's say I have more, but let's say that Ranim is the last one. Ranim. So now I'm looking for Ranim. Ranim, no. Ranim, no. Ranim, no. No, 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 no. I found Ranim at the end. That's the worst case. The one who I'm looking for is in the last of the list. That's the worst case. The best case, if I'm looking for Judy. She's the first one. Judy, yes. Alhamdulillah. I found it. Okay, no need to continue. How about if I'm looking for someone named Salim? Salim. So Salim, no. Salim, no. Salim, no. Salim, no. No, 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 no. I didn't find Salim. So I have to go through the whole list till find Salim. If I didn't find it, then just exit without any return. I might, at that time, just display a message says not found. That is the idea of linear search. So every item is checked, and if a match is found, then that particular item is returned. Otherwise, search continue till the end of the data. So that's why it will take big O of n, because I have to go to the end. That is the worst case. طبعا if I am lucky enough I will find it first one. But when we talk about the analysis, no, we take the worst case. So the worst case that I will go through all of them. Look at the pseudocode and the algorithm. You will find that for each item in the list, check match item with the value I'm looking for. طبعا. So if they are matching, return. Return, it means خلاص, will not continue. Will not continue. Otherwise, we'll keep going till the end. That is the linear search. That is. So, go ahead. Question? Comment? Okay. Let's say that I'm searching for 31. So 31, no, 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 no. Yes, found, return. Searching for 44. No, 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 no. Yes, found, yes. Searching for 65. No, 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 no. Again, I might display a message that, sorry, element not found. I think it's very easy. It's very easy. Questions? Any questions? No. Next, binary search. This is very interesting. And myself, I like this one. The binary search. The binary search is a fast search algorithm with a complexity of log n. Allah يحفظ إن شاء الله. log n. log n. اوكي هنا كانت big O of n. هنا log n يعني much better, faster. The search algorithm works on the principle of divide and conquer. So we will divide the list into sublists. Tamam? Very important thing here. The data collection should be sorted to get the maximum. Now you will know why that list should be sorted. Why that list should be sorted. Then, in binary search looks at a particular item by comparing the middle item. Middle item. For example, now I have a list. Okay, I'm looking for 44. So in the linear, I have start from the beginning. In the binary search, I will start from the middle. From the middle. Okay, I will start from the middle. Then, if match the middle, I'm talking about the middle now. If matching, return the value. Return what I want to return. If the middle is greater, this is very important. If the middle is greater, then the item searched in the sub-array, in the sub-list, to the left. Otherwise it means what? Less. So it will be to the right. It will be to the right. Before we start, let's look here. Let's say the middle is 27. Let's say that the middle is 27. I am looking for 35. I am looking for 35. So in the linear, 35 false, 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 true. So it took me 1, 2, 3, 4, 5, 6, 7, 8 attempts, tries, محاولات, till reach to the 35. Now, in the binary search, I will go directly to the middle. Is it 35? False. Is it greater than or less than? It's very clear now, is the 35 is greater than the middle. So, my number I am looking for could be where? To the left side or right side. ليش؟ لأنه it is greater than. So It is ordered. See now, why is it important to be sorted? So if it is greater than, so the number is to that side. For sure it is not in that side. In one try, in one attempt, في محاولة واحدة, I eliminated all of these because 35 will never come here. So instead of going one after one, I did it only one time. I know that 35 now, it's not here. Do you know that? What does it mean? Do you know that? What does it mean? If I'm looking in a database has 1 million records. 1 million بني آدم. So I'm looking for someone named Zahir. So in English, Zahir supposed to be where? From your experience, is it at the beginning or at the end? Zahir. At the end, yes. Starting with letter A. Ahmed, Anwar, Akram, As'ad, Amir, Arwa. Then B. Badr, Bilal, Budur. Then go next until you reach to the letter Z. So if I am looking for Zahir using the linear, it means I will go from one. Zahir, false, false, false. See how long will it take to reach to Zahir? It's a long time. Now, if I am using the binary, I will go to the middle. يعني roughly كده, roughly. What is the middle of the 1 million? Roughly. Anyone? What is the middle of the 1 million? From 1 to million. What is the middle? Exactly. تفضل. Go. تفضل. صح كده؟ Half a million. So I will not start from 1. I will go directly to middle. So equal Zahir? No, it is Mansour. So Zahir bigger or Mansour? Which one is bigger? Z or M? Exactly. So now in one step, I eliminated the 500,000 search. In one step. See how it is smart, that one? That's why I like it. It's a very smart one. In binary search, in one step, I eliminated the 500,000. Amazing enough. I will ask you a question. Now, I am sure that Zahir is not here. Zahir, if he's there, maybe he's not there, but if he's there, he's somewhere here, from 500,000 to 1 million. So now, can you tell me what is the next step? Quickly, anyone? What is the next step? Where should I search?
The next index to the end.
Aywa, someone said 750. The middle from 500,000 to the 1 million, the middle is 750,000. هذا الميدل. وصح كلامك to the end. I agree with you. But in order to search, so I have to go to the middle. So that is the middle now. Now, are you Zahir? No, I am أميمة. هنا محمد. هنا أو هنا قلنا مين؟ منصور. ممكن ناسي والله. أميمة. So, مين أكبر? Which one is bigger, larger? Zahir or أميمة? If we sort them. Zahir or Umayma? Exactly. So, in the second step, I eliminated 250,000. 250,000 attempts. So, in 2 steps now, I reach somewhere here. In 2 steps, I reach somewhere here. Questions? Is it clear? Is it clear?
Doctor, why we didn't search on the left side?
ليش يا أختي؟ في واحد اسمه أحمد، تمام؟ وفي واحدة اسمها أروى، تمام؟ وفي واحد اسمه محمد، في واحد اسمه نبيل، تمام؟ في واحد اسمه زياد. لاحظي معي الآن، لو أنا أدور على محمد، لو أنا هنا الآن، هنا علي، تمام؟ هنا علي. الآن شوفي من أختي الكريمة، أنا هنا الآن لما أقول أنا أنت علي أنت محمد، يقول لي لا، محمد حيكون لليسار ولا لليمين؟ الطبيعي لأنه مرتبين الآن. بلاش دي أرقام 1 2 3 4 5 مرتبين order، تمام؟ Now I'm looking for number 6. جيت هنا، أنت number 6 are you number 6؟ No I am 4. 6 is greater than. أنت يا أختي الكريمة الآن جواب أبغى منك. 6 ممكن تكون هنا.
Yes, I understand.
You got it? Okay, so 6 will never come to the left. 6 must be هنا نفس الفكرة. They are sorted. So ظاهر at the end أكيد لأنه حرف الزد. Will never come to the left. لازم يكون to the right. شكرا أختي الكريمة. Okay, that is the idea of the binary search. Very interesting. By the way, now for almost يمكن more than 25 years still one of the most important. في طبعا أشياء كثير جات لكن still. طيب, see how the binary search work now. I already explained it. Okay, that's another example now. Now, for a binary search to work, it is mandatory for the target to be sorted. Must be sorted. We shall learn the process of binary search with vectorial example. The following is our sorted array: 10, 14, 19, 26, 27. It is sorted. We are going to look for 31. Okay, we are going to look for the 31. Now, what is the middle item? Easy, don't worry. Apply that formula. Low. What is the lowest location? 0. Don't worry about the numbers. Don't worry about the names, because you can search names, you can search cities, you can search numbers, you can search grades, you can search ages, dates. We don't care. The location is what we care about. So the lowest location is 0. So that is 0. Plus height. What is the maximum location right now? 9. So that is 9. Minus low. We said low is 0. So now low plus open brackets, high minus low is 9 minus 0 divided by 2. The answer is 4. Someone will tell Mr. Shaikhan 9, because that is 9. 9 divided by 2 is 4.5. Yeah, it's enough to take the integer. That's fine. So what is the item in location 4? What is the item in location 4 in my list? Exactly, 27. So now, exactly, 27. So now you will compare 31 with 27. Are they equal? No. Which one is bigger? The number we are looking for, which is 31, is bigger than 27. So 31 could be where? In that side. So forget about 10, 14, 19, 26, 27. Forget about them. So now our concern is these numbers. So now we compare the value sorted at location 4 with the value being searched, which is 31. So we'll find that at location 4 is 27, which is not matched. So as the value is greater than 27, because 31 is greater than 27, so we have sorted array. That's why we said what? So now we know that the target value must be in the upper portion of the array, يعني somewhere. Will never come here. What is the next step? Anyone? سريع. نبغى بالمايك. Anyone mic عشان البقية يستفيدوا get benefit. Anyone? What is the next step? So now 31 is not here. It's supposed to be here. So what should I do next?
Comparing
There's about 27.
Again? Again?
نسوي كومبير ب 27 لل 31 ونشوف هي اكبر
أوكي.
من او تساوي.
اوكي طيب اختي الكريمه ايش كان مشاركتك؟ هو قال
I said we're searching about the middle number again.
Okay.
27.
Now, exactly. طبعا. Now, someone will say, okay, since it's not here, خلاص, it is 31. طب, okay, by luck now it is yes, that I'm looking for, but it's not necessarily the case. So you must again deal with the rest of elements as an array. That's why we said what? Divide. Okay, so now هنا يمكن أوضح. Okay, all of that one list, but now we divided them into two halves. Then that one will be divided into two halves. Then we'll do so. We must know what is the next middle. Exactly. We must know what is the next middle. So now the law was 0. So now 0 is not anymore with us. 1 not anymore. 2 not anymore. So what is now the new law? Value, location. Can anyone guess? What is the new one?
27.
No, I'm talking about the location. Here we said the mid 5. Someone said 5. Mid is what? The lowest value in the list. I'm talking not value as a content. No, I'm talking about index. So that 0 is the minimum number, 9 is the maximum number. So to know the middle, low, which is 0, plus high, which is 9, minus low, which is 0 divided by 2. So that's why we know now the 4 is the middle. So now 0, 1, 2, 3, 4 is not there anymore. So what is the low value now? Someone in the chat said 5. Okay, let's see. We change our law. It was 0. Now it is not anymore 0. So we have to change the law to mid plus 1. The mid was 4. So now 4, we will remove it with the others. So our new law is mid regardless of the number. Mid plus 1. So now 5 is the new law. If you look at the array, it's very clear now that all these numbers are enabled. Disabled. خلاص. We will not use them. So now this is my new list. 5, 6, 7, 8, 9. So how to calculate now? The mid, same way. Low, which is 5, plus high, still 9, minus low, which is 5, divided by 2. So the mid is 7. Any question? So now my new mid is 7. 5 plus 9 equal what? Divided by 2. That is my new mid. Clear? So far so good? Is it clear?
دكتور
تفضلي.
اللو في الحالة الأولى دائما حيكون 0 صح؟
Yes, دائما. If you start from the beginning, all the time 0. But you don't know. Let's say إنه أنا I'm looking for 19. 19. So 27 equal 19? No, less. So in that case, أختي الكريمة, I will ignore all of these. So my number is supposed to be somewhere here. So still 0, but the high will not be 9. It will be 4 next time. لأنه أنا رقمي is less than. So it's supposed to be somewhere here, not somewhere there.
تمام.
وصلت؟
ايوه وصلت.
Okay, so now question. I'm looking for 31. I'm looking for 31, but now my middle is 7. So 31 equal 35 matching. 35 false. It is not. Is it bigger or smaller? It is smaller because 31 is, forget about that one. 31 I'm looking for is less than 35. So this time you will ignore 7, 8, 9. خلاص. For sure my 31 will not be there. 31 could be there. خلاص. Now eliminate those ones. So now what is my low value after eliminating those numbers? اللي هي 35 وال 42 وال 44. What is my low number? My low index? Anyone? What is my low index? 35. Low index. Not values هنا. I'm talking about that.
5.
لا. أنا معلش أنا قلت no. I'm looking reading the chat. 5 is the lowest one. Yes. What is the maximum number? The maximum index.
9.
لا خلاص احنا we said
7.
with 7 already eliminated.
6.
Yes. It seems you got confused a little bit. It seems to me you got confused. Repeat it. Repeat. Should I repeat? You got confused. Good. Control A. Don't save. صلوا على الحبيب. Go back. شوفوا معي. الله يحفظكم جميعا. 10 14 19 26 27 31 33 35 42 44. Okay, these are the numbers. Forget now about the PowerPoint. Now, that location is 0. That location is 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, now we have a very simple idea. I'm looking for the number 31. Into, you can tell now, yes, Dr.Shaikhan, very clear, 31 is there. Okay, but how can I find it? The binary search says the following. I have to start from the middle. I have to start from the middle. So now, maybe today I have 10 items, tomorrow I might have a 1 million item. So how can find the middle? How can I know the middle? The middle is basically low plus high minus low divided by 2. So now when I say these mid to low high, I am talking about the index. Forget about the numbers because it could be names, it could be cities. So I'm looking for the indexes. Now, the lowest number is 0. The lowest index, let's use the word index. The lowest index is 0. The maximum is 9. The high is 1. So low, which is 0, high, which is 9, low, which is 0 divided by 2. So now 0 plus 9, because there is a bracket here, divided by 2. The answer is 4.5. We just care about the integer. So 4 is the location we are looking for. So that is my middle. I'm looking for 31. Now, the value in location 4, does it equal 31? Answer is no, false, it's not. So now, my target is not there. ما هي موجودة هنا, unfortunately. Okay, it's not here. Is it greater than or equal than? They are talking about the value I'm looking for. It's greater than. So 31 will never come here. So forget about all the numbers here. Forget about them. 31, if it is in the list, will never come in that place. So forget about all of these. Now, just by looking, now I have a new list from 5 to 9. So what is the lowest index? What is the lowest index? The lowest index is 5. Exactly. What is the maximum index? What is the maximum index?
7.
What is the maximum index? هم عشان مغطين عليك في الشارع.
9.
أيوه 9. Okay, so the maximum index is 9. So now we are right here. شايفين؟ هنا. 5 or 9. But again, forget the slides. Let's just work في paintbrush. Now, you will apply the same اللي هي what the rules says. Low, which is 5. And هو ده فعلا ده minimum. Plus height. Plus افتح قوس. The height is 9. Minus 5, which is the low. Minus 5, which is the low, divided by 2. So what is the result here? What is the result?
2.5.
7. 7. ليش؟ 9 عندي brackets هنا صح؟ So 9 minus 5 is what? 4. 4 is in 5 plus 4 divided by 2. Division before plus. So 4 divided by 2 is 2. So now it is 5 plus 2. So equal 7. So that is my new middle. Clear? Clear? So that is my new middle. Now I will ask, Mumtaz, I will ask 31 equal to the value in location 7? No. Now, when I said no, it could be somewhere to the left, it could be somewhere to the right. It could be none of them. لا هي left ولا هي right. The number is not there. Okay, but now I don't know. I have to check. So now 31 is not equal to the 35. Ask another question. Is it bigger or less? It is less. When you say less, so 31 will not be here anymore. Will not be here for sure. Will not be here for sure. So now 31, if it is there, it will be either in 5 or in 6. Now, what is the middle? What is the lowest value? عفوا, lowest or low index. What is 5? What is the high index? High index 6. Apply the rule مرة ثانية. So what is the middle now? 5 or 6? يلا انتوا قولوا لي. I have 5 and 6. Apply 5. The middle. You said 5. تمام? Now, if it is 5, found. If it is 6, not found, eliminate it again. So I have mid and low are having the same number. لكن خلينا الآن في 5. أنت you said 5. So let's now continue. Let's continue. Now the value sorted at 7 is not matching because 35 is there. Rather than it is more. So now we have تمام ممتاز. So now hence we calculate the mid again. المid جاي من فين؟ من 5 and 6. Someone said 5.5, so it will be 5. طبعا if someone said 6, still acceptable. Still acceptable. Okay. So now you will compare it with the location file. We find it's matching 31. So now if you said yes, it's Dr.Shaikhan, it is 5. كيف عرفنا انها 5؟ 5 plus 6 minus 5. Okay, 5 plus 6 because that is the high now, minus 5 divided by 2. So 6 minus 5 is 1. 1 divided by plus the 5. So they say خلاص it is 5. 31 equals 31. Yes, fine. That is the idea of the binary search. أتمنى تفضل.
معلش افرض لو ان القيمة اللي نبحث عليها هي 26 مش 31 يعني ورا.
ممتاز.
يعني
احسنتي. جود. انت الان قلتي 26 صح؟ طيب ايش اللي حيحصل اختي الكيس الان؟ I will go to the middle. لا انا هديكي I will go to the middle مش 27 صح؟
ايه
اوكي 26 equal 27 no. طيب ال 26 less ولا greater 27؟
greater.
لا 26 هل هي greater than
small less.
خلاص اذا هذه كلها مع السلامه. جود باي كلها. So now 26 هي حتكون هنا لانها less than 27. So it could be هنا. Now I will خلاص eliminate that one وسيرش هنا to the left.
قصدي ان اللو حيكون مش مد زائد 1 حيكون مد ناقص 1 صح؟
بارك الله فيك. الهاي قصدك انت. اوكي اكزاكتلي انت صح.
لا قصدي اللو.
لا اللو ستيل زيرو لانه انت you are looking for 26.
لا قصدي انه كل مرة حينقص مش حيزيد زي لما يكون قدام.
شوفي 0 1 2 3 4 5 6 7 8 9 تمام. انت الان you are in the 4 هنا looking for هذا اللوست وذات is the high صح لا؟
صح.
So that is the middle. 4 is the middle. Now انت looking for 26 وهنا في 27. So ال 26 equal to the 27 no. طيب ال 26 less or greater less معناه somewhere هنا. So now كل هذيلا out كلهم out. So the low remains zero صح؟ الهايت الان الجديده ايش حتساوي؟ انا فهمت فكرتك اختي. الهايت الجديده مين حتكون بدون مجاملات؟ مين الهايت الجديده؟
3.
يا سلام عليك اللي هي m-1.
ايوه هذا قصدي m-1.
انا قلت لك فهمت قصدك والله فهمت قصدك انا انت انه ناو مش اللو بس انت قلتي اللو لخبطت شويه. نو اللو will remain the same zero. So that's high. So my new high is m-1. احسنتي. So كل ده الان ما تفيدني خلاص انا هنا I'm looking for somewhere هنا. تمام اختي؟
ايوه تمام يعطيك العافيه.
Any other questions regarding this one؟ ترى انا شخصيا يعني when I يعني write some programs وكذا I do it I like binary search. I very يعني amazing يعني تخيلوا يعني if there is a database in China كم عدد سكان الصين؟ What is the population of China؟ أحد عنده خبر؟
مليار.
Okay. So what is the middle of that number اللي قلت لي عليه؟ So يعني هنا مثلا I'm talking about هنا 1000 that is a million that is what؟ هذا مليار ولا أنا غلطان؟ Yeah. Now I'm looking for someone named تمام named Muzigu. Muzigu is somewhere in the middle, not in the beginning, not at the end. So in one step, do you know how many records I will eliminate in one try؟ نص المليار كم؟ أو البليون ولا أي كان الرقم. What is the half of that number؟ أحد يعرف كم؟
500 مليون.
In one step, I will eliminate 500 million. In one step. يا جماعة متخيلين how الالجوريثم is working? In one step. In one step, I will eliminate. ليش؟ لأنه that is the middle. There are هنا 500 million, هنا 500 million. So, مو زي هو somewhere في الام. So I ask the middle, are you me zuhu? No. Bigger or less? Bigger. So when I say bigger, it means me who zu somewhere here. خلاص. So in one step, I'm sure that he's not here. 500 million records. Very fast. Very fast. طيب. Someone will tell me, Dr.Shaikhan, I'm looking for number 10. I'm looking for number 10. ركزوا معايا الآن. Linear search. How many steps will take me to reach number 10? First step only. Are you number 10? Yes, found. Do you know, if I'm looking for the binary, for 10 in binary search, I will go to that 27. Are you 10? No. Less or more? Less. So 10 now somewhere here. I will go to the middle. It could be this, could be this. Are you 10? No. Less or more? So I will take 3 steps to reach 10. So how do you say that binary search is faster? Anyone has an answer to this question? If I look for 10 in the linear, I'll find it from the first time. If I'm looking for 10 in the binary, I will find it after 3 attempts because I have to go to the middle, then go to the middle, then find it. Yeah, I need someone think كده with me and tell me, how do you say, Mr. Shaikhan, that binary is the best and the fastest, and now you yourself proved that it is not.
دكتور بالبيج أو إنه الأسوأ حالة.
Okay. أنا أتفق معاكي. You are right. Excellent answer. And one thing else. Now, there are some abnormal cases. In general, if we have a small list, linear will be good. If you have big list, binary for sure is the best. In general, it is the fastest. In general, it is the fastest. نفسها طويل. Okay, يعني if for big data, binary is excellent. Excellent. Any questions so far? أي سؤال، أي استفسار، أي شيء؟ So far so good يعني. طيب طبعا that is the code that might help اللي هو pseudo code يعني. Okay, you will have lower bound, you have an upper bound, then you will try to find the mid الكبيرة. Yes, exactly with big number. تمام. And every time I will compare it with the mid. صحيح. Okay. هذه ببساطة الidea of the code يعني it's already there برضه you don't need to do it. طبعا احنا we are talking about log n اللي هي complexity big O. Here's the code using simple implementation. هذا the code if you are using recursive. شفتوا كيف هنا؟ Now الحمد لله يعني I'm sure that I'm following also your grades in the quizzes. ما شاء الله you are doing an excellent job in general يعني all of you or most of you doing an excellent job. هنا الcode if you are using simple implementation. So you have midpoint first اللي يقصد the low plus last اللي هي ده divided by 2. So if equal then found. If it's not, you will ask, is it less than ولا greater than? Less than, نرجع للأخت الكريمة قبل شوية اللي قالت لي mid minus 1. If it is less than, mid minus 1. If it is greater than, then the first is mid plus 1. طبعا very simple one. وهنا it's the same code using recursive. It's calling itself. It's calling binary search. So it is calling itself. If you wanna try it, you can apply any one of them. Both of them are working fine. Quick select. تحبوا تاخذوا بريك 10 minutes نصلي ونرجع ولا تصلوا بعد على راحتكم؟ انا ادور على واحد يصلي معايا ماني لاقي لحد الان، مش اتصل على زميلي اللي جنبي هنا. اذا بس نصلي خلاص 10 minutes. يلا بسم الله ناخذ بريك 10 minutes وكونتينيو وذ الكويك سيلكشن. احنا اوريدي ما شاء الله وصلنا النص عموما، يعني وصلنا النص اوريدي. خلاص let's take 10 minutes break. Come back and continue. يلا على بركة الله. بسم الله. نروح نصلي ونرجع ان شاء الله. Question before we continue? Any questions? Let's go. Quick select. Right after learning the quick sort algorithm. Okay, طبعا هنا the author is talking. Okay, the author is talking. After learning the quick sort algorithm, and that what we took last meeting. In one of my algorithm classes, had an author هنا, we learned a quick select. So it's little bit related with each other. A quick sort will quick select. Quick select algorithm is a selection algorithm. So you will select something, you will find something, you will search for something, where a quick sort is just sorting. Okay, so quick select, find, a quick sort, just sort. Okay, طبعا basically quick select is that essentially the quick sort algorithm, except that only needs to recursively call only one side and send it and find something ببساطة كده. The problem is that we have unordered list of the items and want to find the k smallest. That is my concern today. That is our concern today. That you have a list and you need to find the k smallest or what? Largest. Not necessarily smallest. It could be also the largest. In another word, you have a numbers. So you say, I need to find the largest number, the first largest number, the second largest number, the first smallest number, the second smallest number, and so on. So kth means you will put which one of them. Is it the first one or the second one or the third one, and so on. In order to do that, you must sort them. You must sort them. That's basically the idea. Now, we will go a little bit faster here because we have already got the idea of the sorting. Quick select is randomized selection algorithm based on prone and search. So you will pick a random number. If you remember, we called that a pivot number for quick sort. So we'll select a number, then we'll start comparing the other numbers based on that number. And then we will have L less than that number, the number you picked. You will look for all numbers less than that number or equal to it or greater than it. So now you have a list, you have numbers. So you said, I will pick X. So now you must have all the L numbers, which is less than X, all the G number, which is greater than X. So you will sort them based on that. Now, if they are sorted, you say, for example, I need the largest number. Very clear, largest number will be that one. I need the second largest, for sure that it will be that one. The third largest, for sure will be that one. If you said I need the smallest number, for sure that is the small. If they are ordered, that is the smallest one. Second smallest, third small. That is the idea of the quick sort. طبعا in order to do that you must again have partitions. So you have one for the large, one for the smaller, one for the equal. Large equal or greater, or عفوا less equal or greater. Okay, that is the idea. Now, if they are ordered, then it will take big O of 1 time to know the largest one, because it's ordered. So the largest one is in the last location. But in general, the partition step of quick select will take big O of n, because every time you will start compare it with 1. So it will take that one for the sorting, but for finding, no, it will be big one for finding that one. Here is sample code for that one. It's already there, and you can't find it anywhere. Last for today, hash table. Hash table. Anyone get any idea about hashing? What does it mean, hashing? مر عليكم مصطلح. Have you ever heard about hashing?
I think it's related to encryption.
Encryption.
I've heard about it before.
Yes, there is something similar. طبعا احنا هنا a little bit far away from encryption, but they use something similar to that one. الكويك سيلكت. ايش ما فهمتوا في الكويك سيلكت؟ Which one is not clear في الكويك سيلكت؟ Let's go back to quick select. Quick select, you will have 3 sub lists. تمام؟ One, any, you will select elements equal to whatsoever. So that is the list. You selected that one as what? That one. That is a random number. It could be anyone. It could be anyone. We call it a pivot في الquick sorting. Now, all the numbers less than that one will be in a group اللي هي هذه less than. L is element less than X that we selected randomly. All the elements equal to that number, if there is equal numbers, then it will be in E. طبعا generally we find only one. ليش؟ Like when you are searching for students, we never find 2 students with the same number. And I'm talking generally, okay? Searching for مثلا citizens, okay? So no 2 citizens will have the same national ID. أعطيك لستة أرقام. هنا عندك number 2 تمام؟ و1 و5 و4 و3. Now you will pick number, any number you want, any number. Okay, so we will say 4. Okay, so that is 4. Then you will start building 2 lists, or 3 عفوا. 1 for less than, 1 for equal, 1 for greater. So now the numbers less than 4 is what? 1, 2, 3. So that is 1, that is 2, that is 3. Anything that is L less than. Now any numbers equal to 4, no. So that is the only E we have, equal. Okay, greater than is 5. So that is greater than. Okay, let's go to the slide. So now we have X that is equal, which is that one. Those are all the elements less than that number. G is all the elements less, greater than G. So those are now the list. Yes, طبعا. نعم. Yes, you are right. And that's what we said. يمكن جيت شوية متأخر أنت أو أنتي. Okay, yes, we said that we are now connecting between the quick sort and the quick select. Quick select, find selection, find the number, find the name, find whatsoever, where a quick sort is sorting the algorithm. Okay, so what you said is correct. So now, okay, alhamdulillah. Okay, let's go back to the hash. So hash table is data structure which stores data in associative manner. كلمة associate, what does it mean? When you associate something to someone or some element, what does it mean, associate? يعني you have two numbers مثلا 1 and 3. So you are associating. What does it mean, associate? Associate. Connect. Yeah, very close to connect. That's true. So you are connecting between two values and there is a relation. There is a relation. You know, it's not randomly. No, there is a relation. Let's see now. In hash table, data is stored in array format. خلاص, very clear now. We will store data في الهاش table. We call it hash table, but actually we are using an array where each data value has its own unique index. Very important. Here we will come to the association. Unique index value. Access of data becomes very fast if we know the index. If we know the index. Thus, it becomes data structure in which insertion and search operations are very fast, irrespective to the size of data. Hash table uses an array as storage medium and uses a hash technique. This is very important. You must know today how to do the hash technique to generate an index where an element is to be inserted or to be located. Located means searched, okay, to find an element. Let's see. Very easy. We can implement a hash table by using list with each element initialized to the special Python value none. None means nothing, empty, null, blank. The figure below shows a hash table size M11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So M size is 11. Although the end is 10, because we started from 0, so that's why it is 11. In other words, there are 11 slots, M slots, 11 slots in table named 0 through 10. Now, mapping يا دخيل الله الله يحفظك المايك والكاميرا الله يبارك لك. اوكي. Now, the mapping between item and slot, mapping association means associate. Okay, mapping associate. You are mapping from now here, mapping from 1 to 3. Okay, that is mapping or associating. Okay, mapping between the item and slot where the item belongs to in a hash table is called hash functions. Important. Hash function. The hash function will take any item in collection and return an integer in range of slot names 0 to m-1. 0, 0, m-1, maximum is 10. That's why it's -1. Assume that we have set of integers. Okay, now we have a numbers. Our first hash function, sometimes referred to remainder method, simply takes an item and divides it by table size, returning remainder as what? H item, H real hash. Okay, item mod 11. So if you do that, 0 will take the 77. شايفين 77 will go to 0. 26 will go to 4. 93 will go to 5. 17 will go to 6. 31 will go to 9. 54 will go to 10. Note that 6 of the 11 slots are now occupied. This referred to as a load factor. So the load factors is the number of slots occupied and is commonly denoted as number of items divided by table size. In our case here is 6 divided by 11. لو كانت أسماء great. Now if they are names, now in order to get the association طبعا how can you divide name by number؟ صح ولا لا؟ So now you will associate يعني one of the solution you will associate number to each name. يعني أنت الآن name أنت your name is أحمد, but in order to deal with you we will associate to you a number اللي هو student ID. Okay, now when you come to me, you tell me مثلا I need to search for you. I will not search using your name. I will search using a student ID. So you can also associate number. Here. Okay, you can associate number. طبعا هنا it has to be number because we are using an operation. يعني you cannot divide أحمد. لا هذيك different. No هذيك different. ليش؟ إنه we are using arrays هنا. When you search هنا KF تتذكر تكلمنا عن هذه KMB find next. شوف find next will do what you are saying اللي هي string searching. طبعا it can be done but it's almost complicated. It's complicated, very complicated by the way. تمام, but it can be done but very complicated. Okay, now فين كنا نحن؟ معلش double thank you. Yes, right here. Okay, yeah. Now, anyone have a problem of why did we located, associated, mapped in that way? على أي أساس؟ Anyone got any problem? Is it clear why 77 is here, not there مثلا, for example? Is it clear? All? ما في objection? إذا ما في خلاص I'll go to the next. Okay, now we have some issues with hashing. The most important one is collision. It is possible. You might find two numbers that can go to the 0. You might find 100 numbers that will go to the 0. Maybe you have numbers in a certain pattern that all of them should go to the number 0. هذه collisions يسموها. Okay, multiple keys can hash to the same slot. That is a problem. It's a big problem. It will happen for sure. Collisions are possible. So design hash functions such that collisions are minimized. Avoiding collisions is impossible. No way. You cannot avoid it. مستحيل. يعني as long as you use the hashing, so collisions are possible. Actually here, impossible to avoid it. So design collision resolution techniques. You have to do something to solve that one. طبعا search will take big of n in the worst case. However, all operations can be made to have expected complexity of big one, because now since you know where is the number, you can go directly and pick it up. Now, collision problem. It can be solved by methods of resolutions. We have here two ways. First one, open addressing, what is called linear probing. That's number one. Number two, chaining. So to solve the problem of collisions, we have two solutions here. Open addressing, linear probing, and chaining. Let's see. In the first one, all elements stored in hash table itself. All of them will be stored here. All of them. When collisions occur, if there is two numbers, yes, only one, it's enough. Yani to solve the problem, you can use any one of them. It's number one or number two. Now, when collision happens, occur, use systematic, consistent procedure to store elements in free slots. Now you have some free slots here. Now, can you give me a number that if it is here, so it will go to the zero? أحد يقدر يجيب لي رقم هنا. Now I will add it in front of you.
22.
So, huh?
22.
22. Okay. Our brother said if we have 22 now, so it, as he said, it will go to the number 0. Okay? 22. Divided by 11, because our hashing function here is the 11. Okay, so 22 divided by 11 is 2. 2 multiplied by 11, 22. Remaining is 0. So it should go to 0. So he is right. He is correct. So if there is 22, it should go there. Now there is a collision. There is a collision. What is the solution? Here. The solution, you can use that one, you can use that one. If you use the open linear, see what you will do. Linear. As we can see, it may happen that hashing technique is used to create already used index. هذا in our case now. 77 and 22 will map to the 0. واللي مش فاهمها أنا حاسس كده ما أدري عندي إحساس. If you have 77 اللي first time, okay, divided by 11, that is 7. 7 multiplied by 11, that is 77. So what is the remaining? 0. So 77 map to 0. 22 map to the 0. For those who are confused about why they are both matching the same number. Okay? Now, in such a case, we can no problem. Allah, inshallah khair ya Rab. Inshallah khair. Go ahead. Go ahead. No problem. We can search the next empty location. That is in the first one, linear. We can search the next empty location in the array by looking into the next cells until we find empty cell. So that is the solution, which called linear probing, So now, 77 occupied? Yes. So go to the next. Is there a place? Yes. So put that 22 here. So 22 will come. Simple one. Questions? Any questions? So basically, search for the next available place. example هنا طبعا في example هنا if you want to look for it شوفوا هنا P1 so 1 mod 20 20 هنا means what we have 20 items so 1 mod 20 array index is 1 okay after linear probing it will go to the 1 2 2 mod 20 is 2 so array index is 2 so after linear probing it will be 2 42 42 mod 20 equal 2 now we have a problem we have 2 and 42 mapping to the 2 so 2 is already equivalent by 2 so it will take the next one which is 3 clear is it clear you must have ليش لانه نحن based on that one we created the hash based on what based on the size so we said that size 11 I counted for you from 0 to 10 so you cannot have more that number if you have one more so you must increase the size to 12 you must increase the size so next time it will not be mod 11 it will be mod 12 clear ممتاز so that's the first one you are welcome so that is the first solution اللي هي open so just go now if you are searching for 77 so you will say 77 mod 11 so you will know the location of 77 your problem with the 22 now if you say 22 mod 11 it will say also 0 you will go there it's not 22 it is 27 so now based on the technique you used you will go to the next 22 yes we found it طبعا هنا problem so if you are looking for 33 same idea 33 is supposed to be in 0 so 77 occupied 22 occupied empty so 33 will be here and so on so when you search you have to go through all of them when you search you have to go through all of them if it's not found طبعا if it is found no problem okay that is the idea of linear problem طبعا هنا an example 54 or 26 or 93 17 and we added also some numbers so you will discover here طبعا if you go through the example here when we attempted place 44 in slot number 0 هذه similar to 22 حق الأخ الكريم okay so now 44 if you divided by 11 what will happen answer is 4
0
exactly 4 multiplied by 11 which is 44 remaining is 0 so same idea 44 will match with 0 will hash to 0 so نرجع هنا when we attempt to place 44 اللي هي new one هذه جبناها الآن ضفناها into slot 0 a collision occurs under linear probing we look sequentially slot by slot until we find an open position in this case we find slot number 1 like we did in 22 we will find it so we will locate it نفس الفكرة 55 should go also to 0 we said 33 okay we'll go to the 0 so but must be placed in slot number 2 لأنه هنا 77 occupied next occupied so 55 will go to the third 20 for تروح فين 20 control 20 divided by 11 the answer is 1 multiplied by 11 20 minus 11
9
9. So نحن we are concerning about the 9 not the 1. نحن يهمنا ال 9 مش ال 1. نحن remaining. Okay. So now is there any number في 9? Let's see. في 9 في yes 31. ليش؟ 31 divided by 11. كم الجواب؟ 2. 2 multiplied by 11 22. كم remaining?
9.
9. So that's why 31, exactly. So that's why in 31 it's already there from previous one. So now where should I put that one? 20. Now that is occupied. Go to the next. Occupied. Go to the next. Occupied. 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 There is space here. So put it here. Okay, so in order to do that hash to slot 9, since slot 9 is full في space already في item, we begin to do linear probing. تمام. We visit slot 10. شوف نحن وصلنا 10, that's the end. So now you will start from the beginning. We visit slot 10. Then there is a number there. Next. Next طبعا no next, so it will go to the beginning. 0. 77 already occupied. Go to the 1, occupied. Go to the 2, occupied. Go to the 3, nothing there. So put 20 there. Okay. Once we have built a hash table using open addressing and linear probing, it is essential now that we utilize the same method to search. So now I'm searching for 77. Easy. Divided by 11. We'll take the remaining, it's there. 44, you will do the same. But when you go to the, you will find 77. So what is the next? Next, is it 44? Yes, alhamdulillah, done. وهكذا دواليك. So that is the idea of the first solution. Any questions? Is it clear? طيب. Another solution اللي هي number 2. Shading. Shading. I think إنها also smart idea. By the way, the whole course, if you think about it, that very smart. The course, believe me, trust me, it will develop يعني the sense of finding solutions and better solutions, smart solutions. We studied linked lists. You remember that. We studied linked lists. Look at chaining solution. Very interesting. Alternative method for handling a collision. Now, 2 or 3 or 4 numbers mapping to the same slot. شفناها قبل شوية. 77 و 44 و 55 mapping to the same slot اللي هو 0. Okay? Is to allow each slot to hold a reference to collection. So instead of having only one value, new value, sorry, there is no place for you, go find another one. Here, no. In the chaining, each slot, 0 is an example, hold a reference to collection or chain, من هنا جات كلمة chaining, of items, group of items. Chaining allows many items to exist at the same location. So 77, 44, 55, all of them will be in 0. How? When collision happens, the item still placed in the proper slot of hash table. As more and more items hash to the same location, the difficulty of searching for an item in the collection increases طبعا. The figure below shows that one, هي نفس المثال الأول, the same example, as they are added. So we want to search for an item, we use a hash function to generate نفس الفكرة, same idea. The only difference here is that we have linked list. So now, when you are looking for 44, so 44 is mapping to 0. So are you 44? No. 44? Yes. But I will not search in the others. Our problem here that you will go search in others, all of them. So now, if you have 99, still in the 0. 88, still in the 0. So you know that your number, your target number is somewhere here. And maybe it's not there. But at the end, 88, for example. 88, no. 88, no. 88, no. Not found. So I don't care about the rest. In this one, no. I have to go to search. 88, no. 88, no. 88, no. No, 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 no. Not found. While here, I will just search only the 0. Only the 0. That is the concept, the idea of chain. Using linked list. Linked list. تمام؟ هذه chaining. Store all elements that hash to the same slot in linked list. Store all elements that hash to the same slot in linked list. Store pointer to the head of the linked list. So 0, yes, go search in the 0. 1, just go to the 1. 2, just go to the 2. وهكذا تمام. Clear? Is it clear? أي question هنا؟ أي سؤال؟ أي استفسار؟
Clear.
ممتاز.
So will we add like infinite slots according
Yes,
to the situation?
exactly. Now you can add. يعني جاء واحد in the exam. طبعا انتوا lucky انه مثلا هنقول والله لكن if in the يعني exam here in the university and you studied that one and you got the idea الحمد لله. So someone brought you that list. 11, 22, 33, 44, 55, 66, 77 وممكن اروح زياده بس انا حكتفي بهذيل الان 88 99 now هذا exam question now. Yes, if you are using الهاش table, show how you will make الassociation. Okay, represent them. عارف حتكون هذه منظرها كيف؟ اولا how many items 1 2 3 الى اخره. Okay, so ممتاز. So if you have that array, so that is 0, then that is number 10 مثلا for example. So all of these numbers will come here. وهذا empty هنا. So now انت you care about divided by that mode, you will go to the same number every time, search here. So that is a solution. So that's, yes, it can be expanded as you want. اللينك ليست هذه ما عندك مشكلة. Is it smart solution? Yes, it is a smart solution. Performance. We stated earlier that the best case hashing would be big of 1. Constant time search techniques, however, due to collisions, طبعا هنا collisions, that is making the problem. The number of comparisons typically not so simple because every time you have to check, is there a collision or not? Even though a complete analysis of hashing is beyond the scope of this text. يعني we don't need it in this يعني course, M269, but we can state some well-known results that approximate the number of comparisons necessary to search data. يعني you can guess it. You can guess it. That's it for today. Question, comment, anything you want to participate with me, share with me.
I have a question.
Go ahead. تفضل حبيبي.
في اللينير بوزيشن
ايوه.
لو كان التابل عنده 11 سلوت.
ايوه.
عنده 12 element.
طيب خلينا اول عشان احنا we have brothers here who doesn't speak Arabic. What you said is we have 11 slots, but
yes,
we have 12. No,
12
that
elements.
will never happen because if you have, نرجع للأصل, go to the original one. Here, you have a size. So the size will be decided based on what number of elements you want. So if you said 100, so the mode will be changed to 100, so it is not fixed. So it must be equal to or less طبعا, it's okay. So if you say the size is 100 لازم هنا يكون mod 100. If you say 12 you cannot say 11, ما ينفع. It has to be 12. But it's a good question. تمام? Clear? So no. Yeah, you must decide on the size first. Must. الواجب والله I think we talked about it at the beginning.